Okay, example 2, we are going to be evaluating some logs. And this will be example 2a here. And again, we're going to evaluate each logarithm. And we'll do a few here. Log base 5 of 125. Whenever you're trying to evaluate a log, it probably helps to think about what this means in exponential form. This is what we're trying to find. Pay attention to what your base is. This means 5. Pretend like there's an equal sign here. It equals x. We're trying to find x. We're trying to evaluate what our log is. So 5 to the x power is 125. Well, if you look at your power table, you'll see x is 3. So the log base 5 of 125 is 3. Let's do log base 4 of 32. Again, it helps to think of what this means in exponential form. So I'm going to put that this equals x again. Well, 4 to what power is 32? 4 to the second power is 16. 4 to the third power is 64. Well, shoot, that doesn't work. So it's not going to be a whole number here. When you have something like that and it's not going to be a whole number, think about, is there a number that I could take to a power and get 4? Okay, well, 4 is 2 squared. So let's work with that. Let's rewrite this 4 as 2 squared. So I have 2 squared to the x power equals 32. Well, if I have 2 squared to the x power, a power to a power, I multiply these together. I'd have 2 to the 2x power. And that makes life a lot easier because, I'm going to cover up the 2x for a second. 2 to what power gives me 32? Well, 32 is 2 to the 5th power. So that means this power here that my thumb is covering up has to be 5. So 2x has to equal 5. And we can solve for x from there. X is 5 halves. Divide both sides by 2. So the log base 4 of 32 is 5 halves. All right, these ones are a little complicated, so let's do one more kind of like it. Let's do log base 64 of 1 over 32. This one's even trickier yet because I have that fraction. So a couple things going on here. I'm going to put that x in. Think about what this means as an exponential form. 64 is my base to my log. That's my base for my exponent. 64 to the x power is 1 over 32. All right. And kind of similar to what we did with this one. Well, 64 to, well, there really isn't any power that gets us, any whole number power, I should say, that gets us to 1 over 32. So let's think through the same process we did over here. Is there a number to a power we could use for 64? Well, 64 is 8 squared, but I can't think of 8 to any power that's going to give us 32. Let's think of some more options. I could say it's 4 to the 3rd power. But as we saw here, 4, there wasn't a whole number power that we could take 4 to and get 32. So again, that doesn't really help us. But 64 is also 2 to the 6th power. And that's helpful because I can take 2 to a power and get 32. So I'm going to work with this one. 64 is 2 to the 6th power. So it really gives me 2 to the 6th power to the x equals 1 over 32. Okay, so 2 to the 6x power is 1 over 32. How do I get this fraction over here? 2 to what power is going to give me 1 over 32? How am I going to get that fraction? Well, hopefully when you see that fraction, that makes you think, okay, this exponent that my pen is covering up has to be negative. Well, 2 to what power gives us 32? Like, whole number 32. 2 to the 5th power is 32. So 2 to the negative 5th power would give us 1 over 32. So this exponent that my pen is covering up has to be negative 5. Because I need to have 2 to the negative 5th power. Which means 6x has to be negative 5. Divide both sides by 6. And that tells us the log base 64 of 1 over 32 is negative 5/6. If you're super unsure of yourself and you want to double check, we could take this negative 5/6 and plug it back in. Remember that means 1 over the 6th root of 64 to the 5th power. That'll give us that 1 over 32.